Alright, let me get started by erasing everything here. Because this is from POE that I don't really know anymore. We're gonna cover exponential equations. Who is texting me? Sorry. We're going to be covering vertex of quadratics, but this is applicable to most. Intercept form of quadratics and standard form of quadratics. And sorry about my terrible handwriting. I'm really bad at handwriting on digital screens because they're slippery, but it's fine. We're going to start off with exponential. I would do this on pen and paper, by the way, but I don't have a tripod attachment for my phone, so you're not going to see crap. So let's get started. If this thing could not touch my elbow so I can actually write. An exponential equation is f of x, function of x, is equal to a. I'll explain what a is in a minute. B for base to the power of x plus k. K can be thought of as a vertical shift, but in an exponential equation, you're probably going to want to think of it more as a horizontal asymptote. And a horizontal asymptote is the line, imaginary line. So let's draw a graph here. So if we have a graph that goes like this, this is the imaginary line that the graph will come close to, but it will never touch. This is the horizontal asymptote. Your base, right here, if it's greater than 1, so like 2, 3, 4, or decimals like that, decimals above 1, it will be growth. And if it's less than 1, I have these backwards. I just messed up twice. Okay, if it's greater than 1, it's growing. If it's less than 1, it's shrinking. So this one right here would have more than 1. And an example of someone or a graph that's shrinking look like this. A here is unique. So let me get a bigger graph here. Here's your y-axis. That's not a straight line, but don't mind that. I hope you don't mind that. If it bothers you, I'm so sorry. Let's say that this line goes ahead and crosses like this. Bam, bam. This right here is your y-intercept. And let's say your horizontal asymptote here is y equals 1. Let's say your y-intercept with 2 i's, because I don't know how to spell apparently. So y equal to 3. So the distance between these is 2. And that is this, which can be thought of as your vertical stretch, and this is your vertical shift, right? I forget what this is actually called. So how do you find an exponential equation, you may ask? I don't know. Do the math. That I'm going to show you how to do. Oops. Need that. That's just an X. Alright. Yeah. Hold on. Sorry, I'm back. There's some confusion going on with the news. Okay. So let's see. Let's say when a boiling, no, not a boiling, a hot piece of metal is taken out of a fire at 0 minutes. It was 5,000 degrees Fahrenheit. Um, 1 minute later, it was 3,000 degrees Fahrenheit. When it's placed into the water, there's a pot of water. When it's placed into a pot of water, 1 minute later, it was 3,000 degrees Fahrenheit. The pot of water was 100 degrees Fahrenheit. Just pretend that for whatever reason it's 100 degrees Fahrenheit at room temperature, which means room temperature is 100 degrees Fahrenheit because someone is cold or something. I don't know. Not a good excuse. So we have our points. We have 0, 5,000, 1, 3,000, and a horizontal asymptote of y equals 100. My screen is getting hotter and it's getting harder to write on, but it's fine because it's OBS's fault, the recording software. Without having to graph, already we know A. So that's 5,000 minus 100, or 4900. So we have to start up an equation. F equals x equals 4,900 b to the power of x plus 100, which is our horizontal asymptote. Now at this point I'm going to erase this and replace with y. And next we can plug in our coordinate right here. So it becomes 3,000 equals 4,900 to base power 1 plus 100. So now we do the math. Minus 100, 2,900 equals 4,900 b to the first. B to the first is equivalent to b. Now we need to find, my calculator would turn on. Two 900 divided by 4,900 divided by 4,900, which is 0.592 equals b. So then your final equation would be f of x, or y, if you so desire, 4,900 0.5 times 0.59 to the power of x plus 100. This is our final equation right here. So if you look at it, you can identify 4,900 was the y-intercept minus the asymptote, which is the line that the graph will never reach, but get very, very infinitely close to. But it will never reach it unless you round, but don't do that because it's wrong. This is your base, and here is decay, so it goes shaped like this. and our asymptote, which was our base, was the base temperature of the water, 100 degrees. And you calculated this using all of this over here. And if you have any further questions on this, ask them. For example, if there's a negative here, I don't know how to do that, kind of, but I can show you a little trick I learned from Principles of Engineering, right? My computer's lagging. That is fun. Probably means my computer's getting way too hot for its own good. But I feel like it's fine. So, x to the negative 1 is equal to 5. But x1 is equal to 1, 5. Yeah, so the negative right here, you can just transform that into a 1 over. Or if you have like x equals 25 to the negative 1, then you can do x equals 1 to the 25th. Just a little trick. Now let's do quadratic stuff. A lot of explaining to do here. There's 3 forms, of course. We have your vertex. Actually, you know what? We'll put this in a separate video so you can take a look at this one first.